Good morning, ladies and gentlemen. My name's Tim Boxall. I represent Gree UK as Technical Sales Support Manager. I would like to welcome you all to the Gree UK Cooling from Light, the Future of VRF seminar. Introducing the Gree photovoltaic inverter VRF system, the world's first PV VRF system. I'd like to describe firstly the principles and features of the Gree PV VRF system. Included in the energy flow, we have the PV module or PV array. We have an AC rectifier, AC inverter. We have the national grid, and of course the inverter compressor. The basic principle of the system is to use PV energy directly connected to the DC bus bar within the unit. The main features of this system from Gree are two-way energy flow and residual power that can be fed into the grid. Additional features are some of the components within the inverter unit, the VRF unit, which allow us to control and manage the use of the generated energy. So first of all, we use film capacitors instead of electrolytic capacitors. The main reason for using these is the advantages they give us, such as high voltage resistance, no polarity, and high impulse voltage endurance. They also have a much longer lifespan than electrolytic capacitors, which degrade over a much shorter period of time. We also have direct current, low voltage DC components for much safer operation within the system. We have what we call 4-quadrant commutation technology for better interconnection. So this means that basically we are able to control and manage the DC voltage and the AC voltage very easily. High efficient PV power, so advanced PV direct driven technology, which again all adds to the control of the PV generated power. And then lastly, no neutral line, so this reduces costs, reduces losses, and allows us to control the power in a much better way, increases our power factor and reduces our losses. So let me explain a little bit about the actual unit itself in terms of how it utilises the DC voltage and turns it into useful power. There are basically 5 modes of operation for the system. The first mode, in a perfect world, is when we are generating all the power that we need to run the PV VRF system. So if we have enough sunlight, we have enough or a large enough solar array, solar cell array, we can use all the power generated to operate our system. We'll speak a little bit later about how much power we actually need for an average system. Although an average system is not really something we can talk about very much because they vary dramatically. So that's mode 1. Mode 2 is when we can generate power and we have enough power to run our machine, but we have generated also an excess of power which we can then direct back to the grid. All handled by the DC bus bar and the control management within the PV VRF unit. Mode 3, this is when PV generated power is not sufficient for the VRF consumption, so power is then automatically streamed from the grid. So there is no additional switching, there are no additional components required for this. The management of the voltage in the system and the power generated is such that we can just utilise the power that we are generating for our unit, and if we need some more additional power, then we can take that from the grid. Then we have mode 4, which is when the PV VRF system is not in operation. And in this case, any power generated by the solar array can be literally via the unit directed back through into the grid, into the main AC power supply. Again, no additional components required, already all connected, so we can now be feeding back into the grid. And then finally mode 5, this is when there's no power, PV power generated at all, so therefore we just use the grid power as with a normal VRF system. So the main technical advantages and the parameters of the Gree PV inverter VRF system. So there are 4 here listed. So the PV utilisation ratio is up to 98%. So this means we have very little losses within the unit. So whatever we generate, pretty much all of it, up to 98%, is useful to us in some way or another. Either to use within the unit so that we can use the power generated to run our unit, or if it's too much generated, fed back to the grid. I mentioned the 5 modes. The switchover of the power for those modes is very, very quick. So even if we were to go from mode 1 right the way through to mode 5, 11 milliseconds would be the maximum. Not 10, 11. Okay. Two-way flow and mixed supply of power. So we've already mentioned that, where we have the ability to control the two-way flow of the power either to the unit or to the grid. Harmonics. So for an environmentally friendly condition, less than 4%, which means the quality of the power that we feed back to the grid whenever that is required satisfies the requirements of the grid. So therefore we're not feeding bad power into the grid with interference on it, harmonics or anything like this. Okay, so this is all taken care of within the PV unit. So what about the range? Well, basically these units come in modular form, as with most VRF, and it ranges in its entirety from 25.2 kilowatt module, and then by combining the modules together, we can have up to a maximum of 134 kilowatts in the PV VRF system. The range of indoor units is basically the same as all our VRF indoor units. So we need no special indoor units. We need no special wiring or piping or anything like this apart from, away from what we normally do with our VRF system. So the full range of indoor units is connectable to this system. This is just some of the units available. There are more. So it just shows us that basically we can treat it like it is any other VRF system. The actual component within the outdoor unit, which controls and manages the power flow, is a printed circuit board type unit with other components such as reactors, as I mentioned, the film capacitors, and it's all controlled electronically within the unit itself, and that's a specification of the unit. And one thing you'll notice is that the power factor is 0.99 within this control box. So it's not having any detrimental effect on any external power supply. It's not having, it's rated very highly. The harmonics are less than 4%. So again, we're not causing any problems with interference. We're not getting any interference into it. So it's a very safe system. It can work up to an operation temperature of 60 degrees C and down to minus 25. So again, conditions within the UK mean it's a very usable piece of kit. So I'd like to just talk a little bit about the 7 main core technologies involved in this particular unit. First of all, the PV direct driven technology. So the important point about that phrase is that it is direct. So basically it means we can connect directly from our solar array to the unit. There is a plus and a minus connection on the unit. So where if you've got an array of panels and you have a combining unit, you literally just can wire to the unit itself, and it's directly driven. We also have ternary converting technology. So this is the three main elements that we convert to use for our power flow. We have 4-quadrant commutation technology. Again, I'll explain this in a moment. This is to do with the harmonics. This is to do with the control of power flow in a good way. We have something called dynamic load tracking technology, MPPT, maximum power point tracking. This is something that all solar array has to have. And what this does is this finds the most efficient, the most usable generated power. So the peak power that the panel will generate is used at all times. Okay. We have the PAWM interleaving technology. So with this, basically this is to do with inverter control. So again, built into the machine we have control of inverter for the compressor and for the fan motor. Power generation and consumption management technology. So we have controls which can indicate to us and tell us by way of curves, by way of bar charts, how much power we're generating, how much power we're using, and therefore how much we need to take from the grid or feed back to the grid. All on a nice touch screen, all very user-friendly and easy to understand. Then of course at the bottom here we have our VRF technology. So the VRF technology is the same as we use on other VRF systems, and I'm sure everybody is pretty clued in on that these days as it's been around for some time. So with these main elements it's easy to see the advantages of this system. So first of all, the direct driven technology. As I've already mentioned, we utilise the ratio of PV is up to 98%, and because we only have one item on the buzz bar, then our losses are massively decreased. So energy losses decreased by up to 7%. Every time there is a component in the line, losses will be experienced. Okay, so if you reduce the number of components in the line, then your losses basically are decreased. So what we saw there was a normal system where we have to have grid connected inverters, we have to have conversion from DC to AC. Well, we can get rid of those components because we do it all within the unit and the flow is controlled within the unit. The second one I mentioned was ternary converting technology. So this is where we have the three main components, which is the PV cells, the VRF itself and the power grid. The important point to mention is that it's all built in. Now you don't need any additional components to control this power flow. And as I mentioned before, the switchover time is very fast. And therefore we can reduce also one set of DC to AC converters. 4-quadrant technology, low harmonics, reduced losses, power upload in real time, integrated DC-AC converter, meaning safe, efficient PV energy control. Okay? So just trying to get across that basically with this system, the built-in control and the built-in saving in terms of the losses is a big advantage, and it means also that you don't have to add any additional components. The MPPT technology, so tracking function is built into the system, linked with the energy load. So this means if the machine needs a bit more power from the solar, it will track the DC voltage, the power generated, to determine where's my maximum power point, where's my most efficient power point. Is the solar panel providing that? If the solar panel is providing it, it will take it. If the solar panel isn't, due to a sunlight issue, then it will take it automatically in real time from the grid. Very controllable. So as I mentioned, integrated power management. We've developed a central control system. Go to the next one. We've developed a central control system whereby we can see our connections to see what we've actually got connected to it. We can use graphs here where we've got the curves that shows us basically how much power we're generating, how much power we're using. We can put this data into a format as however we wish. We can view it, we can look at it remotely. So we have interfaces which allow us to connect to this. So we can do remote connection. So we can manage it. And we can understand where we're making our savings. We can understand how good or bad the system might be in terms of the power generation, which helps us, of course, in the long run, if we are feeding back into the grid, helps us understand the efficiency of our system. Very user-friendly, touch screen, easy to understand. We can also produce bar charts and we can produce tables. So this all comes from this one controller. So management of the PV system, very easy. If we look at, again, some of the advantages of this and look a little bit about the history of photothermal and air conditioning. So earlier research suggested, quite low efficiencies, and the difference really with the PV inverter system is it's much higher. So we had a maximum efficiency before, for example, trying to produce energy for photothermal absorption refrigerating systems was as high as only 1.3 in terms of an efficiency rating, whereas this system is around about the 7 to 8 efficiency rating. So you can see a much more efficient system. Then there was some common PV connected to AC before, mainly only used, however, on smaller air conditioning systems. And the reason being for that, because there was some smaller units developed that could directly use the DC voltage as we do here. But because it could only be limited to low power, so it was never really a cost-effective option, because obviously the cost of a small unit didn't really warrant buying large PV array installations. And the big problem they had with these as well, additionally, which of course I've already mentioned we don't have, is that you could not connect it to the grid, because they had no management way of controlling that. So, and then finally here, it basically, if you generate a lot of power, you have to have many segments to control and make sure that power that you've generated is safe and is usable. So therefore you have to put in lots of components in the line. Every time you put a component in, you have losses, as I've mentioned before. There's a lot of engineering work, costs were very high previously. So this particular PV VRF from Gree, because it's one unit, because the technology is built all into one unit, we do away with all those losses and all those additional extra costs. As I've already mentioned, selection of the unit is exactly the same as VRF, normal VRF. So again, we're not asking you to do anything particular, or asking anybody to do anything particularly different to what they would normally do with VRF. The selection is exactly the same. Okay, we'll move a little bit on to looking at the PV side of things. Now, I'll firstly say that I'm not a PV expert. So I had to do research for this presentation to make sure that what I'm telling you is what I believe to be the case. Okay. So Gree themselves say that basically the installed ratio of PV panels should be from 0.9 to 1.1, so 1 to 1. There are many different types of PV panel on the market, so I believe it goes without saying really that the more efficient that your PV panel is, the more power you're going to generate. So it's a careful selection of the right panel. The efficiency of that panel, of course, is paramount in this case to determine how much power you can actually generate. So of course this raises quite a few questions about PV, particularly in the UK. It's a growing and fairly new technology, PV. Previously, in years gone by, a very expensive option. But as you'll see later, the cost of PV installations has reduced dramatically. In the UK, of course, we have very different sunlight conditions. So if you live in Cornwall, you get a lot more sun than if you live in the north of Scotland, as you can see from that little diagram up there. It stands to reason, it's obvious. However, everybody still gets sunlight, obviously, even in the winter. So there exists a thought that we don't get enough sunlight to make a solar panel viable. It's not true. The PV cells work on sunlight, not heat from the sun. So if it's cold but it's sunny, you've still got power. If there's light, there's power. The other thing, of course, is that our winters typically are not as bad, say, for example, as many parts of Central Europe. So we have a fairly temperate climate, which we all know. Okay, so if the solar panels get too hot or indeed too cold, they become less efficient. So you could argue that we actually have quite a good climate for using PV panels, because we get a decent amount of sunlight. We don't ever get way too hot, although it makes you wonder why we're all here, but there we are. And we never get really too cold for PV panels. So our efficiency rating on average over a year of a PV panel would remain quite good. Can we use existing PV panels? Simple answer is yes. Obviously, with PV panels, there's very little maintenance. As long as they're kept reasonably clean and not covered in dust and dirt, and the connections are sound, there is no reason why you couldn't use an existing array of panels. Simple connection, straight to the DC connection on the outdoor unit. So why should I use PV? Well, it's clean, reliable source of energy. It uses the sun's energy to generate clean, green electricity. It can be used directly in your home and business. It's one of the easiest and most beneficial renewable energy technologies. I think that's pretty true to say these days. Solar PV saves you money. Now this is the point where everyone gets probably, hopefully, a little bit more interested. Because we've all heard about the feed-in tariff, and we've probably all heard about the changes to the feed-in tariff. Whatever the changes are, you're still getting paid for some generation of electricity that you feed back to the grid. And as I've already explained, the method of feeding into the grid with this system is very simple. So you can get paid for the solar electricity that you generate. It's also index linked, and you can benefit from that as a business. You'll find the benefit of that is actually enormous. And then the other thing is that PV cuts carbon emissions. So for each unit of electricity generated, the amount of CO2 emitted from a conventional power station is reduced. So over, for example, an example is given here that over 25 years, a 1 kilowatt peak PV array will generate over 18,000 units of electricity, which would equate to over 10 tonnes of CO2. So you're saving money, you're generating electricity for yourself, and you're reducing the CO2 emissions. So a lot of pluses for using PV in that case. Now, of course, PV does rely very heavily on sunlight, obviously, it goes without saying. So we have to think about the position, we have to think about irradiance. Basically, radiance is a measure of the amount of sunlight falling on a given surface. Okay. So it stands to reason more sunlight equals more electricity. The angle of the sun, passing clouds, hazy weather, pollution, how clean your PV panel is, all these things will affect the efficiency and the use of your PV panels. And obviously, if you have a nice array of PV on a roof that's south facing and you have constant sunshine, then you have a very efficient system. But of course this will vary and change as the seasons change, whereby during the winter we have less hours of sun, and in summer we have more. And obviously where you are positioned within the country. So all these things would be important in terms of the selection of the PV panels. However, it's true to say that in the UK, the sunlight quantity and amount that we get actually stays relatively constant year on year. So again, I know we have this thing where we always think, oh my God, I hate the winters because it's always dark and cold and horrible. Maybe, but we still have some sunlight. Now, of course, you know, you will have days where generation is not as good as other days, but over the period of a year, then there is something to be had. The beauty with the Gree system is that whatever you generate, however much power you generate, you can use it. So if it's half a kilowatt or 10 kilowatts, it doesn't matter. It's still directly usable. There is no real downside to it because you can use that power. And even if you're not needing to use the power, you can put it back into the grid. So there's no real downside in that respect. So what about costs? Again, this has come from research that I've done. So basically, the research that I found is that the average cost of solar PV installations has reduced by around 70% since 2010. So of course, as a consequence, the number of PV installations has risen. I'm sure you've all driven and seen these massive farms with PV panels. People aren't going to invest in that sort of thing unless there's something in it for us. So basically, this allows us to see that this is a growing technology. Gree have produced a unit already that basically allows us to use this growing technology in a good way. So what about the feed-in tariff? Well, that changed as from the 8th of February because our friends in Downing Street decided that they didn't want to give us too much money. So basically, what I found is that basically for solar PV installations of under 10 kilowatts, they give you 4.3 pence. Now this is obviously less than you pay for electricity. But when you generate PV, you use what you need for the VRF system. You might use also for other things in your building. Then whatever you don't use, you get some money. So 4.39 pence per kilowatt hour in this case, and then a little bit more for bigger installations. Now, of course, the question arises, how many panels do I need? How much do I need? What sort of space do I need? This is not an easy question to answer because it's going to vary dramatically. And the other question could be, why do I need to do it? Why should I do it? What benefit am I going to get? I think I've explained those benefits to everybody, hopefully. Basically with PV, you have a situation where you could use it. With our system, it's almost a no-brainer because you can use whatever you need. You can feed back into the grid whatever you don't need. Now, in terms of the safety of the system, in terms of the installation of the units, obviously this is a renewable technology, so it will be affected by the MCS in some way or another. This is something that is coming. This is something that we will have to look into and talk about in the future. At the moment, there is no indication of how it would affect this kind of installation, so I can't give you any straight answer on that. But basically, it means that the system at the moment allows us to connect directly to PV, use directly the power, feedback won't do anything we don't want to use. Okay. Does anybody at this point have any questions they would like me to answer? Is that okay, or did you want to do that? Yeah. Anybody have any questions? No? Okay. No problem. Well, thank you all very much for your attention. I hope it explained a little bit about how we're utilising PV power. and how we as a manufacturer have produced a unit that's using this technology. If he bangs that a little bit harder, he might achieve something. So thank you all for listening, and please visit our stand, which is just next door, where you can actually see the unit in reality. Thank you very much.